Now today let's talk about how we can calculate the normal force and the frictional force from those types of surfaces. Can be inclined, can be horizontal, or the force can be at an angle. So let's start from the horizontal one. Let's say we have a box. The box is on a horizontal surface and there is a force acting to the right. So how do we calculate the normal force here and the frictional force? So first we should draw a free body diagram. So the free body diagram in this type of situation, since it's horizontal, and we remember that normal force is always perpendicular to the surface. So this normal force always going up perpendicular to the surface, and there is weight or Fg going down. So we have frictional force going that direction. Remember, frictional force is always the force that opposes the motion of an object. And then we have the force applied going to this direction. So we call it F. So now, how are we going to calculate the normal force? From this type of situation, we know that normal force is equal to weight, and we know weight as mg. So here, how are you going to calculate now the frictional force? We know that the frictional force, or it can be kinetic, is equal to the coefficient of kinetic frictional force multiplied by normal force. So now what is normal force? Normal force is equal to mg, as you can see. So that means this, how are we going to calculate normal force, I mean the frictional force. So we replace normal force with mg. So what is m? M is the mass of an object, the mass of an object. Now what is g? G, this one is in kg. So g is always 9.8 meters per second squared. So this one is the acceleration due to gravity, so it's constant. So this is how we should calculate the frictional force in this type of situation. So let's move to another surface now, or another type of situation. Now let's say we have a horizontal surface like this, and then we have a box on a horizontal surface, and the force acting at an angle, let's say, can be 20 degrees. So now, if you want to calculate, there is a type of free body diagram you should draw, the one that is going to help you to calculate. So let's draw a free body diagram now. So we represent a box with a dot, or the object with a dot. So now, since it's horizontal, normal force going up as always perpendicular to the surface, and we have weight, or Fg, going down, and then we have the frictional force opposing the motion of an object, and then there is this force. So this force is a two-dimensional force. So what are we going to do now? We're going to take its components now. Since it's a two-dimensional force, it has a vertical component and the horizontal component. So since it's acting at an angle up, so we have this force going up as Fy. So this is our vertical component of that F, and then there is this one going straight, we call it Fx. So this is a horizontal component of that force. So now, how are we going to calculate the normal force first? We're going to say how many forces here are going up. So first force is normal force is going up plus the Fy is going up. Now we only have two forces going up. Now how many forces are going down? We only have Fg. So Fg is going down now. So how do we calculate the vertical component of a force? So calculating the vertical component, Fy is equal to F sine, since it's vertical, sine angle. Now what is that angle? Okay, it can be the given angle. Yes, we use the given angle. So now what is the Fg? Fg, we know that Fg is equal to mg. So now we have N is equal to Fg minus Fy. So we took this Fy to the other side. Now, what is Fg? Fg is mg minus, what is Fy? Fy is F sine theta. So that means here we have F sine theta. So now, this is our normal force. So how are we going to calculate the frictional force now? So Fk is equal to the coefficient of kinetic friction multiplied by normal force. Now what is our normal force? This is our normal force. So we're going to say the coefficient of kinetic friction. Now we replace N with mg minus F sine theta. So here we have mg minus F sine theta. So now this is how we're going to calculate the frictional force from this type of situation. So F is this force, is the force or the given force, for example, and theta is the given angle. So that's how we're going to calculate the frictional force. Now let's move to other diagram. Let's say now we have a horizontal surface, we have a box on a horizontal surface. So now we have a force acting at an angle, but now it's going down. So let's call this angle 20. It's fine. So this is force F that's acting at an angle going down now. Now how are we going to calculate the normal force and the frictional force? We start from a free body diagram. This is the free body diagram. So we have normal force always perpendicular to the surface. We have weight going down, or Fg, can be weight or Fg, same thing. So since it's pushing this box in this direction, that means now our frictional force is opposing the motion of an object. So now our frictional force is going that direction. So now remember, this is a two-dimensional force. That means we have to take its components, a vertical component and a horizontal component. So since the force is acting down at an angle, that means now we have Fy going down, and then Fx going straight to the left. So now, how are we going to calculate the normal force? Now we check how many forces are going up. We only have normal force going up. How many forces are going down? We have Fg going down plus Fy. They're both going down, as you can see here. So now what is mg? I mean Fg. Fg is just mg, as we indicated, plus what is Fy? Fy is F sine theta. Remember, is a vertical component of the given force. So now how are we going to calculate the frictional force? So Fk is equal to the coefficient of kinetic friction multiplied by normal force. Now what is our normal force? This is our normal force. So we just substitute the coefficient of kinetic friction, then we have mg plus F sine theta. So now this is how you should calculate the frictional force from this type of situation. Then let's move to the incline one. Let's say now we have a surface, an inclined surface at an let's say angle 30. So we have a box here. The box is going up, or the force is acting up the incline. So the box obviously is moving up the incline. Now, how are we going to calculate the normal force here? Here what we're going to do is we draw a free body diagram. This is the box. So in this type of situation, you make sure that in your free body diagram, you always start with Fg. We know that Fg is always downwards. So this is what we're going to do. We take it straight down, Fg. Then normal force is always perpendicular to the surface. So you look at the surface's incline. So let's say we take normal force like this. We say this is normal force. Now, what is the direction of the force? The force is going this direction, F, and then we have a frictional force opposing the motion of an object, as F. So, but here, since this free body diagram is not the one that you should use to calculate, so now we should take the component of Fg. Since Fg now it has components, or it's a two-dimensional force, it should have the perpendicular component and the parallel component. Now we should draw the other free body diagram. This is what we're going to do. We say normal force perpendicular to the surface, normal force. Then we take this straight, then we call this Fg perpendicular. It always goes with normal force, and then we take this F, the force acting up the incline, and then we have a frictional force. So this is frictional force, and then we have this force. Since this one is a two-dimensional force, it has the perpendicular force, which is Fg perpendicular, and the Fg parallel. So this one, it always acts parallel to the surface. This one always acts perpendicular to the surface. So now, how are we going to calculate the normal force? So we know that the normal force here is equals to Fg perpendicular. So it's equal to Fg perpendicular. Then what is Fg perpendicular? Fg perpendicular is mg cos theta. So we know what is m. M is the mass of an object, g is the gravitational acceleration, and the theta is the given angle. So here in this type of situation, it means that now normal force is equal to mg cos theta. So now this is how we're going to calculate the frictional force. So it's the coefficient of kinetic friction multiplied by normal force. So what is normal force? Normal force is mg cos theta. So we're going to say the coefficient of kinetic friction, now we say is mg cos theta. So now in this type of situation, or on an inclined surface, this is how you should calculate the frictional force.